Welcome to Kshatrani classes. So I am covering your NCERT syllabus, which is related to class 10th state and CBSE. Okay, so firstly, let us take the chapter trigonometry, one of the most important chapter I say for the examination. Okay, so we'll understand the introduction related to the so-called trigonometry. Dears, trigonometry, tri means 3. Okay, so three-sided figure, that is triangle. Trigonometry basically deals with right angled triangle. Now, what is the speciality of trigonometry is that when I talk about the right angled triangle, you know, in right angled triangle, one angle is 90 degree. One angle is 90 degree, and with respect to angle sum property of a triangle, say that sum of all angles of a triangle is equal to 180 degree, where in case we have 190 degree, means to say that suppose if it is a right angle triangle ABC, where in case angle A is equal to 90 degree. Okay, according to the angle sum property, say that angle A plus angle B plus angle C is equal to 180 degree because of angle sum property, where angle A is 90 degree plus angle B plus angle C is equal to 180 degree. Okay, so if I bring this 90 degree to this side, plus turns to be minus, so I get here angle B plus angle C is equal to 180 minus 90, that is equal to 90, means to say that the sum of angle B and angle C is equal to 90 degree. Okay, so if the sum of angle B and angle C is equal to 90 degree, means it is sure that both angle B and angle C are acute angles. Okay, so in right angle triangle, angle A is 90 degree and angle B and angle C are acute angles, means trigonometry can be applied only to acute angles of right angle triangle. And after that, one of the most important thing you have to know about the trigonometry is that trigonometry gives connection between sides and angles. Trigonometry gives connection between sides and angles. So this is what the very speciality related to trigonometry, where in case initially trigonometry was found out by Egyptians and Babylonians for the construction of their perspectives like pyramids and all. So now in the olden days, the trigonometry is used to calculate the distances between the planets and the sun and the planets and the distance between the stars. There are so many applications related to trigonometry. Okay. Related to right angle triangle, according to the side conventions, you people already know that the side which is opposite to 90 degree, okay, the side which is opposite to 90 degree usually called as hypotenuse. And the side which was at the below was called as base, and this is called as altitude, related to right angle triangle. But now according to trigonometry, we have to study the side convention here. Okay, I told you trigonometric ratios are applied only to acute angles of right angled triangle. We are not applying trigonometric ratio to right angle. We are applying trigonometric ratio only to acute angles of right angled triangle, so that with respect to which acute angle you are writing trigonometric ratios, likewise you have to side convince the diagram. Now, with respect to acute angle B, okay, now I'll name the side with respect to acute angle B. Dears, with respect to acute angle B, the side which is opposite to angle B, okay, the side which is opposite to angle B is called as opposite side, okay, is called as opposite side, and the side which is just beside the acute angle B is considered as adjacent side. Adjacent side. This is what the side convention you have to first do before writing all the trigonometric ratios. Okay. Now I have represented the diagram with respect to acute angle BDS. Fine. So the side which is opposite to 90 degrees called as hypotenuse, and the side which is opposite to acute angle is called as opposite side, and the side which is just beside the considered acute angle is called as adjacent side. So the same diagram, okay, I'll consider the same diagram, and in this diagram now we'll try to analyze the sides with respect to angle C. Okay, so now in this diagram we'll try to denote the sides with respect to angle C. As usually, you know, hypotenuse is not going to change. Hypotenuse will remain as it is here, as it is the opposite side related to the so-called 90 degree. Okay, now with respect to angle C, now tell me which is the side opposite to angle C, that is AB, yes or no? Now with respect to angle C, AB will become the opposite side because it is opposite to the considered acute angle, that is angle C. And now this is the side which is beside to the considered angle C, hence it is considered as adjacent side. Okay, so this is how first you need to understand which acute angle you are considering. According to that consideration, you have to name the sides appropriate to that acute angle. As I already told you, trigonometry is the connection between or the relation between the sides and the angle. So we have here the ratios which give the connection between the sides and the angles. And now with respect to trigonometry, we have 6 ratios. Okay, 6 ratios you can able to write with respect to the acute angles which are present in the right angled triangle. Okay, now I have considered acute angle B for my calculation perspective. So now what I am going to do is I will write all 6 trigonometric ratios with respect to angle B. Okay. Now the first trigonometric ratio with respect to angle B I am going to write is sin B. Okay, sin B. In the short form, sin can be just written as SIN, sin B. Okay, sin B. Dear, sin B is the trigonometric ratio where it give the relation between or sin B is defined as the ratio of opposite side divided by hypotenuse. Okay, so sin B is defined as the ratio of opposite side to hypotenuse. According to our diagram, sin B, see opposite side, which is the opposite side dears? AC is the opposite side where BC is the hypotenuse. So sin B can be written as AC divided by BC according to our diagram. Okay, now we'll take the second trigonometric ratio. The second trigonometric ratio is cosine B. Okay, cosine B. In the short form, we are going to write it as cos B. Only COS, cos B. And cos B is the ratio of adjacent side divided by hypotenuse. Cos B is the ratio of adjacent side divided by hypotenuse. And with respect to our diagram, see, adjacent side is AB and hypotenuse is BC. So we'll write it as AB divided by BC. AB divided by BC. So first trigonometric ratio, sin B opposite side by hypotenuse, cos B adjacent side by hypotenuse. Okay. The third trigonometric ratio that we are going to talk with respect to angle B, that is tangent. tangent, tangent of angle B, but in the short form we will be writing it as only tan B, T-A-N, only tan B. And dears, tan B of any acute angle is the ratio of opposite side to adjacent side, opposite side to adjacent side. Tan B of any acute angle is given by the ratio of opposite side to adjacent side. With respect to our diagram, which is the opposite side, we have AC is the opposite side and AB is the adjacent side. So we will be writing it as AC divided by AB. AC divided by AB. Remember very important formulas. Sin B is opposite by hypotenuse. Cos B is adjacent by hypotenuse. Tan B is opposite by adjacent. Okay. Fourth trigonometric ratio is cosecant of angle B. Cosecant of angle B. In the short form, it is considered as cosec B. Cosec B. And dears, cosec B of any acute angle is given by the ratio of hypotenuse to opposite side. Hypotenuse to opposite side. When I write with respect to our diagram, hypotenuse is BC and opposite side is AC. So will be considered as BC divided by AC. This is the fourth trigonometric ratio, that is cosec B. Okay, the next fifth trigonometric ratio that we are going to talk about is so called secant of angle B. Secant of angle B. Why I am using B here? Because we are writing the trigonometric ratios with respect to angle B. So we have to represent the angle. Secant B. In the short form, we will be naming it as sec B. Okay, or sec B as you pronounce. Okay, so sec B is the ratio of hypotenuse to adjacent side. Hypotenuse to adjacent side. Sec B is the ratio of hypotenuse to adjacent side, where in our diagram it is BC divided by AB. BC divided by AB. And the last trigonometric ratio that we are going to study is so called cotangent of angle B. Okay, cotangent of angle B. In the short form, we are naming it as cot B, C-O-T, cot B. And dears, cot B is the ratio of adjacent side to opposite side. Adjacent side to opposite side. Cot B is the ratio of adjacent side to opposite side, where with respect to our diagram, it is AB divided by AC. AB divided by AC. When you observe all 6 trigonometric ratios, you can see here sin B is opposite by hypotenuse, but cosec B is hypotenuse by opposite side. Can I say sin is reciprocal of cosec? See here, hypotenuse by opposite, opposite by hypotenuse. So sin is the reciprocal of cosec, or cosec is the reciprocal of sin. And cos is, see, cos is adjacent by hypotenuse, where sec is hypotenuse by adjacent. So we say cos is the reciprocal of sec. And you can also observe here, tan theta is opposite by adjacent, where cot theta is adjacent by opposite. So these two are also reciprocals to each other, and these are the very important trigonometric ratios. to solve further all the questions, these formulas are very essential to be understand. Okay, so we'll start with the first exercise question. So simple one. Try to understand the question first. In a triangle ABC, right angled at B, AB is 24 centimeter, BC 7 centimeter. Determine sin A cos A tan A, sin C cos C tan C. So first what we have to do is, we will draw the diagram, mark the side, use the formulas and write the ratios. Fine. Okay. Now, triangle ABC is given, and also they have told you right angled at B means where is the B is at the point of right angle. Okay, so now first I'll name this point as B, and after that I'll name here A, B and C. So it is understood that if it is 90 degree, then we are only able to write the trigonometric ratios with respect to angle A and angle C, because we know that trigonometric ratios can be applied only to acute angles of right angle triangle. Fine. Now we'll write with respect to angle A. Okay, so as I told you, first we'll name the diagram and after that we'll proceed. With respect to angle A means the considered angle is angle A. If it is 90 degree, then you know this side is referred as hypotenuse. I'll name just H here, hypotenuse. Okay, and always it is sure that the side which is opposite to 90 degree is considered as hypotenuse. And the considered angle is angle A. Okay, the side which is opposite to the considered angle is opposite side. Yes or no? It is opposite side. And after that, here the side which is beside the considered angle is nothing but adjacent side. Okay, it is adjacent side. Now our diagram is ready with all the sides. AB equal to 24 centimeter means this AB side is how much, dears? 24 centimeter. And BC is given. BC is how much? 7 centimeter. BC is given and AB is given. To write the trigonometric ratios, we know that hypotenuse is also necessary. So we first have to calculate the hypotenuse and after that we'll use the formulas. And you know that in the right angle triangle, if two sides are provided, then am I able to find the third side? Yes, of course. By which theorem? By Pythagoras theorem. And you people know that Pythagoras theorem say that in a right angle triangle, hypotenuse square is equal to sum of squares of other two sides, where in case we know. Yes or no? So I'll write here the Pythagoras theorem. AC square. AC means who here? Hypotenuse. Hypotenuse square is equal to AB square plus BC square. Means what, dear? The hypotenuse square is equal to sum of squares of other two sides in a right angled triangle. Fine. Let me take AB here. What is AB? That is 24. See here, 24 square, and BC is how much? 7 square. 24 square plus 7 square. We have to calculate it very quickly. 24 square is how much? 576 plus 7 square is 49. So we'll add up 9, 6, 15, carry 1, 12, that is 625. AC square is equal to 625, where AC is equal to root 625. We know that the square root of 625 is how much? 25 centimeter. Now we got to know that hypotenuse is nothing but 25 centimeter. Now in the right angle triangle, we are provided with all the necessary information. Now we'll start writing the values here. So we'll write the answer for the first question. Okay. So firstly, it is asked to write sine A. And we have to remember the formula with respect to sine A. What is sine A? Sine A is equal to opposite side divided by hypotenuse. And with respect to our diagram, opposite side, what is the opposite side we have? BC is opposite side, AC is hypotenuse. So we'll be writing BC divided by AC. BC divided by AC. So sine A value is BC is 7 centimeter, AC is 25 centimeter. So sine A is 7 by 25. This is the needed value. Okay. So next one which is asked, cos A is asked. So we'll write cos A here, and again remember the formulas. Cos A is nothing but adjacent side divided by hypotenuse. Okay, with respect to our diagram, which is the adjacent side, we have AB is adjacent side, AC is hypotenuse. So we'll be having this AB divided by AC. Okay, so I'll write the value here. Cos A is equal to AB is 24 and AC is 25. Cos A value is 24 by 25. Okay, now which is the last one they have asked? Tan A. And remember the formula with respect to tan A. Tan A is equal to opposite side divided by adjacent side. So opposite side divided by adjacent side. Opposite is BC and adjacent is AB. So I'll be writing here BC divided by AB. Okay, quickly we'll write the value. Tan A is equal to BC is how much? 7. AB is how much? 24. So we'll be having 7 by 24. So now with respect to angle A, okay, with respect to angle A, we have written sine A, cos A, tan A. That is 7 by 25, 24 by 25, 7 by 24. Okay. Now to write the trigonometric ratio with respect to angle C, we'll rearrange the diagram to make it easier to write. Fine. Okay. To write with respect to angle C, we'll rearrange the diagram. You people will get confused if you just write it in the single diagram. So please make sure that you are redrawing the diagram once again and mark the sides with respect to the angle C. Okay, don't change any values here, any vertices. Okay, just write all the values as it is. This was 24, 25 and 7 centimeter, A, B and C. I have not changed any values and any vertices. But now we are writing the trigonometric ratios with respect to angle C right now. Okay, and you people know that if this is 90 degree, then sure it is hypotenuse, dear. Yes or no? The side which is opposite to 90 degree is hypotenuse. And now with respect to angle C, you know that the side which is opposite to angle C is considered as opposite side. Hence, AB will become the opposite side and BC will become the adjacent side with respect to angle C. Just look the difference between the diagram which was with respect to angle A and the diagram which is with respect to angle C. Values are not changed. Vertices are not changed. Only opposite and adjacent are going to change. Okay, now we'll write the answer for the second question. Okay, so see here. First, let me write sine C. Quickly remember the formula. Sine C. Sine is nothing but opposite divided by hypotenuse. Why I am writing here C? Because I am writing trigonometric ratios with respect to angle C. Okay. Opposite is now AB and hypotenuse is now AC. So which is nothing but AB divided by AC, where I'll write sine C is equal to 24 divided by 25. This is the value associated to sine C. Okay, now we'll write cos C. Cos C. The formula is adjacent adjacent divided by hypotenuse. See here, adjacent is BC and hypotenuse is AC. So I'll be writing here BC divided by AC, where cos C is equal to 7 divided by 25. Okay, so this is the needed information for cos C, and we'll write tan also. Tan C is equal to, what is the formula? Opposite divided by adjacent. Okay, opposite divided by adjacent. According to our diagram, which is the opposite? See, AB is the opposite and BC is adjacent. So we'll be having here AB divided by BC. We'll write the value here quickly. Tan C is equal to AB is 24 and BC is 7. So tan C is equal to 24 by 7.
Thank you for watching. Subscribe for more videos.